Now we have Filipe, who comes all the way from Brazil just to speak to us. Isn't that cool? He's interested in all kinds of programming languages, their communities, and open source, and believes that simple is better than complex, and this should be a mantra for most things in life. And because simple is better than complex, apparently multi-tenant applications are how and why is really simple. So let's give him a hand.
Good afternoon. So before, I'll be talking about multi-tenancy. This is my Twitter handle if you want to follow me. But before that, I have a disclaimer. So as I come from Brazil, it turns out I have a massive jet lag. So if I pass out like anytime, you know what happened. All right, so my name is Filipe. I come from Brazil, which is on the northeast of Brazil. Recife is on northeast of Brazil. And I've been in Australia for 1 year during high school. So, and that has been a long while ago. So just so you have an idea of how long it has been since I've been here, this was happening. Yeah. Nah. This was happening when I was here. All right, so I'm partner and developer at Vinta. We have a playbook where we compiled some of our moves, the way we work, if you want to check out. We also do a lot of open source, so you might want to check out our boilerplate project, Django permissions, and Tapioca, which are both mine projects. Yeah, feel free to go there. So let's start with a bit of context, all right? So I'm not sure how many of you are familiar with enterprise application, but it turns out there is a big market for fidget spinners. I'm not sure if you know about this. Yeah. So the application we'll be dealing here today is a corporate fidget spinner tracking. And this is database schema we are going to be using. So we have a customer, which has users. You have a spinner, which is kind of like the type of the spinner. And then you have a user has one spinner, and you can spin the spinner. Simple enough. All right, so this is how it goes. So you want to sell your corporate fidget spinner software. So you go to the big corporation, and you say, all right, I have this software, you might want it. And the CEO will say, all right, I like it, we do need it. And he says, you now have to talk to the head of IT. And you go to the head of IT, and you explain. She asks a lot of questions. And at some point, she's going to ask you, how do you protect our data? Because big corporation doesn't want to leak their data. So that's the point where you'll be glad you know about multi-tenancy. So what is multi-tenancy at first? From Wikipedia, it says it refers to a software architecture in which a single instance of software runs on a server and serves multiple tenants. Cool. So it's a bit like not straightforward, but like just single instance of software serving multiple tenants. And tenants, every time I say tenants here, you just hear clients. It's pretty, for the context, it's just the same. Or customers. So what we want to achieve here is we want to use multi-tenancy to reduce the infrastructure costs. We want to simplify software, and we want to also simplify infrastructure by having less nodes in our architecture. I'm going to be going through three main structures for multi-tenancy applications. The first one, I'll call it, I mean, there's no official name for none of those. I'll just call, I have a simple name for each, but the first one will be a single shared schema. And it's pretty much what big corporations use. So if you go to Salesforce, they'll be using something like this, for example. And it's simple enough. It's one server, one database, and I mean, it can get a little more complex if you're big, but the baseline is that. And I'm going to be going through the code. I want to show you how to do stuff. So all the examples will be in Django. as expected. So for this, this approach, we're going to be writing middleware. I'm using the new style middleware functions. And the thing we want to do is we are going to access ibm.spinatracking.com. And the first part is really simple. We are just getting the IBM name from the request. And then we fetch the customer from the database. And we set the request.customer to the customer we just fetch. And that's it. You just run your request through your views, and it should work. When you get to the views, the way you're going to query, you just use the request.customer. And from our initial schema I showed, you would have to do all this path to set the customer, because the customer was only related to the spinner. And I'm just getting the average duration here. So it can get a little easier. A good idea in this situation might be just set a customer instance in every single database table. And this will give you some improvements, such as it might be easier to do some sanity check. So maybe, and it also makes it simple to query. So now that we set that, we can filter for customer directly. So as I told you, this is the situation you're going to find in companies such as Salesforce. And just for example, they do, for each database, they have 5,000 clients. So it scales quite well. They have multiple databases, so like they do some kind of routing beyond that, but it scales quite well. So a good thing about being Salesforce is that you are big and you have quite a few developers, so you are able to run software to check stuff. So for every single query they run, they do a automatic checking to make sure there is no data leaking from one customer to another. And this is transparent to developers. So if you're a Salesforce engineer, you don't need to be worrying about it. The drawbacks from this approach, it's a little harder to guarantee isolation because you have to manually do the querying. It might lead to a complex code base, and you might have some trouble with libraries. So if you are integrated with a library that doesn't give you access to the models, you might not be able to add the customer to the table, and I mean, you're going to have an inconsistency in the way you do query through your application. The second approach would be having multiple databases, and that's like the complete opposite of what we just did. We had a single database, we managed manually the schemas through our queries, and now we are going to say, all right, we are having one database for each customer. So something like this. And the way you do this in Django, I think most of you will know. So you have the database configuration. You can set the IBM database, and you can just use the using query from the using method from the query set, and it will work from the manager. But there is a better approach. And I'm pretty sure I'm going to get some bad looks from some of you by showing this, but maybe you can use thread local. And I'm not saying you should use, I'm just saying you can use, all right? So it goes pretty much the same as before. We just get the subdomain, we get a customer, we set the customer in the request, and then we use that decorator to execute our request through the passing this thread local variable, which is using DB, and we pass the customer name. And you do a little bit of customer routing. You just so you use the thread local again to get the instance of the database you're going to use, otherwise default. And that's it. you don't need the using anymore. So you can simplify a little bit. So a question I might ask about this is this really multi-tenancy? Well, it depends on how you see it. If you are a database engineer, maybe you say, no, this is multiple database. But from the application point of view, you are serving multiple clients through one instance of the software. So it can be considered multi-tenancy. The last approach I want to show is the single database with multiple schemas. And that's the most interesting one because not many people know about it. So the way it goes is you have a server, and you have one database with multiple schemas. But what are schemas in the first place? And from now on, every time I talk about schemas, I'm kind of talking only about Postgres because, well, it supports it. If you go to MySQL, it won't support, for example. All right, so every one of us, I mean, if you ever use Postgres, you have already used schemas because by default, it uses a schema. I think I passed. Yeah, so actually. So whenever you do select from ID name, from user, you are already using the default schema from Postgres. The thing is, you are able to create a new schema by using the create schema command. And whenever you do this, you begin to be able to query through that schema. So we have the same query before, but now we are doing it through IBM. So the table is now called IBM.user, and we get the field name from IBM.user.name. But there is a shortcut for this. You can simplify it by setting the search path. And whenever you do set search path to IBM, all the queries that go from from now on in the same connection will be set to IBM dot whatever table you have there. And this can help us a lot. And that takes us to the library called Django Schemas. It's pretty popular. It's really interesting. It does a lot of stuff for you and can help a lot. So we are going back to the middle approach, just like we did on all the examples before. And so again, this is from the source code of Django Schemas. And you see that's pretty much the same thing we've been doing so far. So you get a host name, you get the model, you get the client. You set the request.tenant to your client. And the only thing that changes is the connection.setTenant. That thing we didn't have before, we're going to have now. And I'm going to show you how it works. So in your configuration, you have the routing settings. And you already set the tenant middleware I showed you. And the other thing you are going to change is that you're going to set the database engine to this custom one that comes with tenant schemas. And what it does underneath the hood is it will set the search path for you. So it will automatically do all the hard work for you, so you don't have to worry. And you see the join up there. So it's going to put if you're querying through IBM, it's going to put IBM and comma default. So it will try first IBM. If the table is in the IBM schema, then we return from the IBM schema. Otherwise, you just return whatever if the table will be on the default schema. And it's pretty cool. It comes with a few commands. It orders it changes the create super user command, so you are able to pass a tenant. So you can do create super user minus tenant, something like this, and you pass on the tenant you are looking for. It has this tenant command, so you can run any other command you already have on Django automatically. So what it do is we'll run one time for each schema. And also the migrate schema, so you are able to actually migrate all the schemas at once. So the query gets a lot easier. So when you are in your views, well, what happens is you just query as if it was a normal view. So for instance, here we are annotating the average duration for each type of spinner. And it's going to be doing this only in the IBM schema or whatever other schema you have. So it's transparent. You don't have to worry about this. One thing we might want to do is you might want to query across schemas. And that's a thing that actually gets a little harder. You won't be able to, I mean, you can do it through Django, but it's going to be a little harder. You can do it straight from SQL using a union. But then we have a problem here. The thing is, we are making a union from two separate schemas that are controlling their own IDs on their own. So you might get some clashes, right? So you can do something about this. And one thing you can do is set, instead of having an ID, you can set a UUID, and then you should be safe. You can then make queries on top of this, and it should work. So some upsides. Your queries will be looking just like a normal Django query. You don't have to worry. New schemas get created automatically. Whenever you create a customer instance in your application, you already create the schema, the new schema, and run the migrations. It knows how to handle migrations. So if you're using Django tenant schemas, you already do all the migrations for you. And you get a simple infrastructure. So I mean, you can get many clients in a single server in a single database. Some drawbacks would I mean, I never reached that point, but you might want to be careful with too many schemas. I've read a little bit about it, and it looks like you shouldn't be doing more than a few thousand clients in a single database. Your test might get a little slower because of all the migrations and stuff, and it's going to be hard to consolidate any data, aggregate stuff, because of that. They are in separate schemas, and you need to do that union. But the thing I want to tell you is, so multitenancy is quite. I showed two approaches, but I'm not saying that's all you can do. Multitenancy is a continuous spectrum. You can combine those approaches. You can go with only one of them. You can. I mean, there's many ways to do it. So I hope you can use what you learned today to decide what's better for your application. I have this presentation is at the bit.ly/Django Multitenancy, and I also have example Django application at my GitHub where you can see applying the first two examples. The other one, you just go straight to Django tenant schemas. And I finished a lot earlier than I was prepared for, so I might be able to answer questions. How about it? Yeah, so we have a newsletter if you want to sign up for that. Also have my contacts there, my GitHub, Twitter, and email. Feel free to find me. All right?
We have a fancy stand, so if you want to ask questions, come line up.
One of the multi-tenancy options you suggested was having this customer ID in pretty much in every table. How does that play together with Django Sites framework?
Django.
Django Sites framework, Django Concept Sites. Is that what you're looking for there, or?
Good question. I'm not sure how to answer this.
Okay.
Yeah, I'm not sure. Sorry.
Is there any tools, if you want to move to this system with the schemas, to go from like a single schema system to there?
No, you're probably going to have to do it like manually. So there is no.
Mostly new projects then.
Yeah, yeah.
You've been talking here about the technical aspects, which are obviously an important part of it. How do you convince your customers that the data is safe? Because is it a case of you just don't tell them that it's a multi-tenant database, or do you actually, is there any way you can convince them that no, you're not going to be able to see your competitor's data, or your competitor's not going to be able to see your data?
Well, I think if your client is technical enough, then like if you explain how the multiple schemas thing works, then I guess it shouldn't be a problem. I'm not really sure how to answer this, but I'd say that either you rely on your client being technical enough to understand how it works, or you just say, trust me, it's safe. Which is pretty much what every time you do, so regardless the approach you're doing.
Last call.
Sorry, can you just talk about it?
No, you can't.
No.
You record it.
You mentioned that Salesforce implements some technique to safeguard at a low level the security.
Yeah.
What are some implementation techniques? How do they do that?
I don't have the details. I mean, I've read about it, but I don't have the exact details how they do it. I know it's completely transparent from what I read. Again, I don't have the access to the real thing. I'm just telling what I read through the internet. And but what the article said was that, and this was actually not an article, was a Salesforce presentation on YouTube. And they explained it, so it's some kind of mechanisms. They pass through the query, and they check if the customer ID is the one they are looking for, but it's transparent to the developer doing it.
Have you implemented anything like that?
No, I haven't.
Okay, thanks.
This might be a bit of a naive question, but how does this contrast with just having multiple databases on the same machine? Like, what is the benefit of schemas?
Yeah, so for instance, one thing is you don't have to instantiate a new database. You can just like create the schema from the SQL, but that's not like a real good reason. The other good reason would be from the point of view of maintenance, it's a lot easier to deal only with one instance of the thing than to have multiple stuff. So the reason why I use it is mostly about this. So I don't want to be caring about having multiple instances, multiple nodes. That might get complex as I scale the software. So that's pretty much it.
Okay, thanks.
You said that the you said that the library handles the migrations and stuff for you. From a database perspective, though, if I have 100 schemas, am I running 100 migrations
Yes,
under the
you
covers?
are.
So it's a complete
Yeah, it's
new
a
set of tables.
completely isolated. And this is actually a point it might get dangerous because like if you mess up with one migration, you might mess up with a lot of people. So you have to be careful. A staging ambient might be a good idea. So yeah. Any other questions? All right, thank you.
You get to get your special mug. One more time. Okay, we have another changeover